just to sort of kick this off, um, could you maybe please tell me a bit about your background? How did you wind up at NTT? How did you join NTT? Was this something you always wanted to do all your life, or did it just happen?
Uh, okay, so I was a science kid when I was a high school student, and at that time I was doing my hobby was radio amateur, so telecommunication, and then I got the degree at the I majored in science and engineering, and my thesis was about telecommunication. So that's why naturally I selected NTT as a company that I should work for.
So, where did you start at NTT? Or I have you here, your title as the head of the IOWN Development Office in the R&D Planning Department. I'm sure that's not where you started unless you were just really that good.
I started my career in NTT as a researcher. I joined NTT R&D laboratory, and I spent several years there. And then I moved to NTT Group's operating companies doing fiber broadband access businesses. And then I moved back to NTT Lab again, and then I was transferred to R&D organization called NTT Innovation Institute Inc., which is a lab located in the Silicon Valley of US. And then I moved back to NTT R&D again, and then after that, the current position, the head of IOWN Development Office. So my career in NTT is about broadband network and also cloud computing. So the core part of IOWN is about how we can integrate computing technology and networking technology together so that we can provide ultra broadband and low latency and high energy efficiency infrastructure capability. So I think my career background fits this position.
Yes, it absolutely does. I had the opportunity to visit your facility there in Silicon Valley at the Upgrade Reality event a couple of years ago. Really enjoyed that and learned so much about how NTT is leading when it comes to innovation. So IOWN is a research initiative, but you have spent time in the other operating divisions of NTT. So how does your work in the research organization directly support the information IT services and the network operator business of NTT?
That's a good question. So it's very important for industry like telco to take advantage of the latest technology. The technology is changing very fast, and if we keep doing businesses with old generation technologies, then we will lose customers. So for in my job, for example, I propose the enhancing today's fiber broadband access services with wireless services wireless technologies such as Wi-Fi and so on. And so it's very important to know how the technologies are going and update our business models. And so currently, I think one example is update a fiber broadband access business with Wi-Fi. And I think, of course, the next thing was about a smartphone and also cloud computing and so on. And what we are foreseeing next is how we can adapt high-speed optical communication technologies into today's internet-based infrastructure services. That is the core of IOWN.
Well, I mean, that seems to be a very aggressive adoption of things like cloud computing. The communication service providers have not really been quick to adopt cloud and some of these other advanced technologies as a part of their core. What makes NTT so different?
That's a nice question. I think one thing we can say about this question is we have a lab.
Mm-hmm.
Currently, many telcos lab is getting smaller and smaller in the world, but in Japan, NTT still has a laboratory, and our folks, our research field spans from basic technology to network technology, also to more application layer technologies and topics such as social, society, social and culture, and so on. So we have that R&D, and so we can get we can have big antenna to capture what's going on in the world and adapt and think about how we can update our business model, taking advantage of such trend.
So the global ICT industry today seems to be really focused on the 5G rollout and extending cloud computing to the edge in order to support a lot of these new business models. Is IOWN the NTT vehicle for implementing these incremental improvements?
So I'm going to explain how 5G and cloud can be enhanced with IOWN technology. So this is our view about the issues with today's 5G and cloud. So one of the issues is we would like 5G will provide ultra broadband and low latency radio link. So we'd like to develop applications leveraging such capabilities, but cloud computing infrastructure is connected through packet networks. So if we use servers, computing infrastructure on the cloud, we would not be able to leverage the capability, ultra broadband and low latency nature of 5G radio links. That's why we built edge computing infrastructure called MEC. MEC stands for multi-access edge computing. And but one of the issues with MEC is because with MEC we have to distribute computers into many DCs. So we will spoil the benefit of cloud computing, because the benefit of cloud computing is to have a big pool of computing resources so that we can assign resources with more agility, and also we can achieve enhanced resiliency. And also we can improve the resource utilization with lean resource management. Sometimes we call this concept elasticity. So that's the benefit of cloud. But if we distribute computing pool into many DCs, then we would spoil the benefit of cloud computing. So this is one issue. So with 5G plus edge computing, we cannot operate computing infrastructure as agile as those in cloud computing infrastructure. That's one issue. And another issue is today we should build a 5G radio access infrastructure using physical fibers, connecting antennas and CLAN systems with physical fibers. So we depend too much on physical cabling, and this results in the lack of agility of antenna deployment, and also because each antenna is tied to CLAN systems physically, so we cannot achieve resiliency and elasticity. So that's the issue with radio 5G RAN. So these are the issues. Do you follow this explanation?
Yes, absolutely. So, with these issues with the connectivity and the rollout of the RAN infrastructure, IOWN enhances it using photonic technology?
Yes, that's what I'm going to explain with the next slide. So we will propose the use of IOWN APN. IOWN APN, first of all, APN stands for All Photonics Network. And instead of connecting 2 points with the multi-hop routers and switches, we will create a wavelength path between endpoints, so that the data transfer between these two endpoints can be achieved with guaranteed bandwidth and bounded latency. So typically in metropolitan area, if we connect two endpoints in the same metropolitan area, packet round trip time would be less than 1 millisecond. So it's a great improvement in terms of latency. With today's packet network, the latency is around 10 millisec for the case of metropolitan communication. And also, we would like to note that the latency is varying. So we cannot guarantee the latency. But with IOWN APN, we can guarantee the latency. So with that, what we can do is we can create, as for MEC issues, we can build MEC infrastructure with two-tier architecture, where we have MEC carriers cloud, where the carriers have a large pool of computing resources such as GPU resources and so on. And MEC HDC will connect, it will interact with this MEC carriers cloud with a very very low latency. So we don't have to distribute computing resources to many edge data centers. So that's gonna solve the first issue. And also as for RAN issue, today we depend too much on physical cabling. But if we use IOWN APN in place of physical fiber, basically cabling would be replaced with logical connections.
Okay.
So we can improve the agility of antenna deployment, because what we have to do is to connect antenna to the local access point of IOWN APN, and then create a logical path from that access point to the CLAN system. This will also make the CLAN network resilient, because if one data center fails, then we can switch the front haul connection to the other data center. And also, we can improve the resource assignment of radio access network. For example, during the daytime, basically the traffic will be high in office areas. But during the nighttime, the traffic will be high in residential areas. So because we have this APN as for the connection between antenna and CLAN systems, what we could do is during the lunchtime, we can connect more antennas to CLAN system. We can connect more antennas in office areas to the CLAN system. And during the nighttime, we can connect more antennas in the residential areas to the CLAN system. So we can dynamically switch the connection, and that would improve the energy efficiency of RAN system.
So, one of the big advantages that's often touted about 5G wireless is the concept of network slicing, where you can use different network slices to manage the quality of a connection based upon the type of data or the user. As you transition into the all photonic network, are you using wavelength as sort of a network slicing capability?
Yes, that's a good question. So it's a good APN will be a good complementary to 5G slicing. So with 5G slicing, we can have multiple classes of radio links.
Mm-hmm.
But in order to extend these differentiated services over to the cloud, we need some network that can handle, that can provide connections with multiple classes, and APN can be a good infrastructure to support that capability. We can have a multiple wavelength. We can use multiple wavelengths to provide differentiated services. And one of the important advantage of APN compared with other packet switching technologies is we can provide connections with guaranteed bandwidth, bounded latency,
Mm-hmm.
no no delay variation. That would be a good advantage because people are interested in developing very low latency applications with 5G.
Wow, sounds good. And so the APN, or the All Photonic Network, seems to be foundational to IOWN. But there are two other components, the digital twin computing and the cognitive foundation. Can you tell us a bit more about those components?
Yes, so yes, digital twin computing is another important concept of ION, and what we will do is, of course, many people are now developing digital twin applications, but our view is that with internet and cloud, uh, digital twin systems that we can develop have some issues. One is silos. Many people develop data sync systems, but most of them are very small systems, and they are systems in silos, so they cannot interact with other digital twin systems to achieve society-wide optimization. And also, data velocity is limited. What I mean by that is even if some data are captured in the physical world, the time when the data analysis system on the cloud can recognize the updated data and do and derive some reaction is a few, sometimes several minutes later or several hours later from the time that from the time when changes happen in the physical world.
Mm-hmm.
And also, data sharing is very limited. Sometimes we would like to have different digital systems exchange data, but typically we have to go through the data transfer from one data lake to the other, and it takes very time. It is very time consuming.
Mm-hmm.
So these are the issues. And also the connectivity is with limited bandwidth. So that's another issue. So what we can do with IOWN is we're going to have IOWN APN as the core, and we can create multiple data centers with IOWN APN so that data can be exchanged with high bandwidth. And also we will create a distributed database infrastructure called IOWN Data Hub. And this IOWN Data Hub will provide a database or storage interface to many digital twin application systems so that multiple digital twin application systems can share some database or storage so that this will allow us to have multiple digital twin systems that function collaboratively to achieve society-wide optimization. And this will allow us to accelerate the data velocity and more, and also promote data sharing across multiple digital twin systems. So this could be done, of course, with IOWN APN. We will build a distributed database, high-speed distributed database, leveraging IOWN APN's high-speed, low-latency connection. This is a digital twin computing. And next, I'm going to explain what cognitive foundation is. So cognitive foundation aims to achieve the coordination among different layers, such as optical transport layer or mobile network layer and computing layer. Today, basically, the infrastructure are operated with layer by layer concept. So each layer is operated without knowledge about what's going on in upper layers or lower layers. But for example, we operate optical network without knowing where are the mobile users are concentrated at this time, and also where the cloud computing workload are in high. So, but if we have, if we can optimize the transport, the topology of optical transport links with knowledge about the distribution of 5G traffic or the distribution of cloud computing workload, then we can improve the resource efficiency. So, and this will be very important for sustainability of the society. So what we would do is to do the total optimization through the coordination between these layers. I mean, optical transport, radio, network, and computing infrastructure.
Wow. So a lot of your explanation contained references to how IOWN actually can improve the global society. It's not surprising since NTT has always been focused on improving. And it's a key component of the company's culture. So, what other ways does IOWN address that aspect of the company's culture?
By the way, let me add one thing. The
Sure.
point, the reason why we say cognitive foundation is we would like to develop this coordination mechanism like as autonomous as possible. So the ideally, we would like to make this kind of coordination
Yeah.
operated with an autonomous driving experience. That is why we say cognitive foundation. And regarding the last question,
Yeah. One a follow up on that one is this how using the cognitive foundation is this how the digital twins can actually interact? Because I think that's a very unique aspect of IOWN.
yes, that's true. So of course, digital twin is intended to provide support digital twin applications of customers, but at the same time, of course, we're gonna build a digital twin based operation system for infrastructure,
Mm-hmm.
and that would be the foundation of cognitive foundation. Yeah.
Great, thank you. And you are going to address some of the additional ways IOWN supports our society?
Great. That's a great question. So, one of the contribution that we can make is contribution to the decarbonization of data center infrastructure. Today, data centers are becoming bigger and bigger,
Mm-hmm.
and it is consuming huge energy. And in many cities, societies have started resisting against the construction of hyperscale data
Yeah.
centers. Some cities had started posting a data center moratorium, which means the cities will ban the construction of new hyperscale data centers for a few years. But what IOWN APN can do is we will make the concept of cloud from centralization to decentralization. Instead of having a few limited number of hyperscale data centers, we can create many small size or medium sized data centers that are operable with locally available green energy, and connect these small or medium-sized data centers with IOWN APN so that customers can have virtually one big data center. This would allow us to leverage.
Is this what I've read about disaggregating computing?
Yes, disaggregated computing is the concept to leverage such data center architecture. You don't have to have disaggregated computing system. Even with today's computing system, if we decentralize data centers with IOWN APN, we can solve the energy issues, because if we can distribute energy demands over a wide area,
Mm-hmm.
then leveraging green energy would be more easy.
Understood. So this new approach to computing actually can reduce greenhouse gas emissions by reducing the amount of energy that's used by these hyperscale data centers, and also distributing them in a more across a broader geography, so that you could have these data centers in areas that are using sustainable energy sources?
In order to achieve carbon neutral, carbon net zero, what is important is not just reduce the total energy consumption. What is also important is to reduce the peak power demand per area.
Mm-hmm.
We would like to avoid creating a spot where where there is a huge energy demand in a small area. We would like to avoid having such spot. Instead, if we could distribute power demand over a wide area, then it would be easy for us to leverage green energy. That is something that we can achieve with IOWN APN.
Wow, that's very impressive. But you're not doing this all by yourself, are you? You have this IOWN Global Forum. So how does NTT leverage the forum in order to bring IOWN into a reality?
Oh, that's a great question. So in IOWN Global Forum, there are many influential companies in the world. Most of influential companies in the world are now members. Influential companies in the IT and network industry are now members of IOWN Global Forum. And there we are discussing society issues and use cases or application system to solve such society issues. And then we identify the architectures or system architectures of application systems to solve society issues. And then through these discussions, we will create a consensus between service providers and equipment vendors regarding what kind of IT product and the network product will be needed. And then IOWN Global Forum members will develop products, IOWN compliant network products and computing products. So, and at the same time, we will do some kind of POC activities with IOWN Global Forum members, so that we can demonstrate the value of IOWN Global Forum technologies and application systems to the world.
Wow, thank you. I really appreciate the detailed information that you have provided. And Kawashima-san, you've really given me a much better understanding of IOWN and how this new approach is really going to help in the creation of a smarter world. So, have we missed anything that the audience should know?
Having received your question, I think society's impact of IOWN. So, as I said earlier, IOWN will make a paradigm shift in the cloud computing. So today, cloud is about centralization, and this is creating several issues. One is data center moratorium or energy sustainability issues. And the other thing is data sovereignty. So now cloud is getting bigger and bigger. On the other hand, customers' on-premises infrastructure is getting smaller and smaller, but many customers are concerned about data sovereignty. But with IOWN APN, cloud will be about decentralization. We can allow data centers distributed over multiple regions, and also we can allow customers to have their own small DC as a part of the whole cloud infrastructure. And this will allow customers to keep data sovereignty for their own data. So IOWN will change cloud from centralization to decentralization.
So data sovereignty is a very important aspect of a modern cloud strategy. And it also has a big impact when it comes to laws and regulations. So IOWN seems to help in the protection of data. Is that what you're saying? Could you maybe explain that a little more?
Yes. So because with IOWN APN today, because the network is slow, so in order to leverage a cloud computing infrastructure, customer has to store their data in the cloud.
Mm-hmm.
But because IOWN APN is a high-speed, low-latency infrastructure that can connect multiple data centers, so customers can store their data at their customers' own DCs. But at the same time, if they want to analyze their data, they can transfer their data to the cloud in a relatively short time and do the processing leveraging cloud providers' computing infrastructure. Of course, they may be concerned about the data leakage while data are being processed in cloud infrastructure, but that can be protected with today's secure computing technologies such as confidential computing and so on. So with that, we can separate data centers to store data and data centers to execute computing. So maybe in future, cloud will be called computing centers, and customers' data centers would be called data centers.
Wow, excellent, excellent. So, what is the best way of learning more about IOWN and how it's going to really change the ICT industry?
The best way to learn the latest activity of IOWN, maybe please check the NTT's press release, and also please check the IOWN Global Forum's press release.
And is there if someone wanted to reach out to you to learn more about IOWN, how could they contact you?
Yeah, I would be delighted to accept such contact. Thank you.
Would that be through LinkedIn? Is that the best way?
Could be through LinkedIn, or I think there should be some contact address on NTT R&D's webpage.
Okay, so we'll use the NTT. Okay, on the NTT R&D webpage.
Yeah. Yeah.
Wow. So we really appreciate you taking the time to speak with us today, Kawashima-san.
Thank you very much for having me.
Could you maybe forward me a copy of these slides? The other ones, there's been some changes, and I really like this particular one, and especially on how the society's impacts on NTT. So thank you very much. That was very, very informative.
Thank you.